Suppose that transformation T1 from vector space V to vector space W and transformation T2, also from vector space V to vector space W, are linear transformations. Let T1 minus T2 of x equal T1 of x minus T2 of x. Prove that the function T1 minus T2 is also a linear transformation.
First off, a transformation is a linear transformation if it is additive and homogeneous. A transformation T is additive if for any vectors A and B that the transformation is defined for, T of A plus B equals T of A plus T of B. A transformation T is homogeneous if for any vector A that is defined in the transformation at any scalar C, T of C times A equals C times T of A. With that said, in order to prove that function T1 minus T2 is a linear transformation, it must satisfy this equation and this equation. Before we start proving these equations, remember that T1 minus T2 of x equals T1 of x minus T2 of x. Let's start by proving the additive property of T1 minus T2. So that would mean that T1 minus T2 of A plus B has to equal T1 minus T2 of A plus T1 minus T2 of B. Thanks to this equation here, we can rewrite the left side as T1 of A plus B minus T2 of A plus B. It is given that T1 is a linear transformation, so it fulfills the additive property. That means we can rewrite this as T1 of A plus T1 of B. It is also given that T2 is a linear transformation, so it also fulfills the additive property. So we can rewrite that one as T2 of A plus T2 of B. Distributing the negative here, we get T1 of A plus T1 of B minus T2 of A minus T2 of B. As for the right side, we can use this equation to expand this and this. So that would mean the right side is equal to T1 of A minus T2 of A plus T1 of B minus T2 of B. With the commutative property of addition, we can rearrange the left side to equal T1 of A minus T2 of A plus T1 of B minus T2 of B. And this is equal to the right side, which is also T1 of A minus T2 of A plus T1 of B minus T2 of B. Therefore, T1 minus T2 of A plus B equals T1 minus T2 of A plus T1 minus T2 of B. As this equation is true, that means that T1 minus T2 is additive. In order for T1 minus T2 to be a linear transformation, it also has to be homogeneous, which means that it fulfills this equation. In other words, T1 minus T2 of some constant c times a vector A has to equal the same constant c times the transformation T1 minus T2 of A. using this equation here, we can expand the left side to be T1 of C times A minus T2 of C times A. As it is given that T1 is a linear transformation, that means it fulfills this equation here, meaning that this would equal C times T1 of A. Likewise, T2 is also a linear transformation, and it fulfills this equation. So this would equal C T2 to the A. We can then take out the C, and that would equal C times the quantity of T1 to the A minus T2 to the A. Expanding the right side according to this equation gives us C times the quantity of T1 of A minus T2 of A, which is equal to the left side. This means that the original equation, T1 minus T2 of C times A, equals C times T1 minus T2 of A. As this equation is true, that means that T1 minus T2 is homogeneous. As T1 minus T2 is additive and homogeneous, that means that T1 minus T2 is a linear transformation.